Alright guys, we are going to add to our new chapter, special lines inside of triangles. So in our table of contents, this first big chunk of information that we're going to talk about are those special segments. So when I say a special segment, what I mean is a line inside of a triangle or inside and outside of a triangle that is sort of unique or special or has certain properties about it that help us do math with it. So these are our special line segments. And we're actually going to be doing these on a lot of different pages. I want to put 52 to 56 here. And then I'm going to kind of specify by each one that we're doing, like which page you can find it on. So the two that I want to talk about today are perpendicular bisectors and angle bisectors. And really, we've already talked about these a little bit, so that's kind of nice. And we're going to do those. Those are going to be on page 52. So both of those are on 52 and 53. So if you remember, we didn't put anything on this one. It's not numbered. We're going to turn the page and take a look. So we're actually not going to fill out a lot of this right now because if you look inside, there's kind of some crazy stuff going on here, and there's some other words that we haven't talked about yet. So we're going to kind of fill some of this out now and some of it out later. So like I said, a perpendicular bisector and an angle bisector, we've already talked about a little bit. So really what a perpendicular bisector is means that you are working with a 90-degree angle and a line segment cut in half. So a line segment being cut in half. Now that being said, that can get us a lot of different things depending on the type of triangle or just other things that we can use that we already know. So if we actually jump over here now, some perpendicular bisector math facts. Like we said, on the side that the perpendicular bisector touches, so on the side that it crosses, we get this 90-degree angle, which that can be helpful and mathy because if I know that it's 90, I can like set a little baby equation up to equal 90 and solve for x. And then the other thing that we said is it cuts that side in half equally. So I might be able to set one side equal to the other, or if I know one of the sides is like 5, I can double it 10 to get the entire length of the side. Or if I know the entire length of the side is something like 18, I can take half and get each piece would be 9. So there's lots of different equations that we could write for that. The only other thing I think I want to say here is if your triangle is equilateral or if it's isosceles and the perpendicular bisector is going through the non-congruent angle, which that's a little bit of a special case, then your perpendicular bisector will go through the angle on the opposite side. It doesn't have to. So like all of these examples right here are either isosceles or equilateral triangle. So bisector goes through angle on the other side. Because I could have something where I have like this scalene looking triangle, and if I perpendicularly bisect this side right here, I'm cutting it in half at a 90-degree angle, and when I do that, this line doesn't necessarily go through the angle opposite of it. You know, it may if it's isosceles or equilateral, but it may not. So now using those math facts, we can do different things with it. So we can see our perpendicular bisector right here, but if I wanted to find HG, that's not a part of the perpendicular bisector. However, we can use what we learned last chapter, this reflexive side right here, and we have congruent triangles by side angle side. So if this is 14, that would have to be 14. So just because this is talking about a perpendicular bisector, I have other math facts that I can use to solve for stuff. Like similarly here, again, SQ is my perpendicular bisector because it is perpendicularly bisecting this side here. But again, it's talking about these two sides here. But again, I can say that the two triangles are congruent by side angle side. So if I want to solve for x to get PQ, I can set those two things equal. Subtract the x both sides, add the 1, so we get 3 equals x, so that I can find that this side is 5. And then down here, same deal. So we have this perpendicular bisector, and I can tell because it was perpendicularly bisected, meaning if this side here is 12, so is that. So I've found AD is 12. Whole line would be 24. And again, just like with all the other ones, if this perpendicular bisector goes through the angle on the other side, then the two triangles are congruent. And so we can say that 3x plus 1 equals 2x plus 6. I would subtract the 2x both sides, subtract the 1, and get that x is 5. And then I can plug her in for BC right there and get 16. And so that one would be 16 as well. Okay, now the other one we have is an angle bisector. And an angle bisector means that we are working with kind of really array, but what happens when I bisect an angle is I'm dealing with congruent angles. And that's because when I cut it in half, each side's the same, so we can set stuff equal. We can use our little baby formulas to do that. So some angle bisector math facts that we can use. Like I said, when we are cutting an angle in half, we can set stuff equal. So it's really array because it starts at an angle and like shoots out from it. So it's kind of got an endpoint and then an arrow that goes out. So it's really array that cuts an angle in half. Now again, that can be helpful because I can set each side equal, or if I know one of the smaller ones, I can double that. So like if the smaller angle, like half of it is 50, then the whole thing is 100. Or if I know that the entire angle is 70, then I know that each part is 35 because I split that in half equally. And again, if we have that it is going through the angle opposite, then we can get congruent triangle stuff, which is kind of what's going on in these examples here. So I can see that this angle has been bisected because each side is marked with one rainbow, meaning that they are the same. So if this angle over here is 38, so is that one. And if it happens to go through an angle on the other side, then we get congruent triangles again. But I think all we needed to find was JKM, so I have. And similarly here, so I can see that this angle M was bisected because we have rainbows on both sides. And I have congruent triangles by angle side because I have this reflexive thing in the center. So these sides would be corresponding. So I could set them equal. So if I do that, I would actually subtract the 2x, giving me a negative x over here, which is kind of a bummer. But then it works out because I want to change them both positive. So x is 3. And then LK would also be 3 because it's just x. Now, another thing that we've done before with angle bisectors is if they tell me that ray BD is the bisector of ABC, I can set these two sides equal. So to find the value of x, I would just say 55 equals x plus 12, subtract the 12, So x is 43. Okay, so kind of easy, I think. A little bit of a review. And yeah, I think that's it for today. Hopefully it goes fine.